When constructing a proof, we're going to make a series of statements, and every statement we make, we have to provide a justification for that statement. How do we know that's true? So in our first proof, we have to prove that angle D is equal to angle B. Now we can see angle D and angle B are vertically opposite angles, so we know they are equal, but we can't just say that. That's a statement. That's not a proof. In order to prove it, we have to bring in another piece of information. So we have two additional angles we could use, and there's multiple ways we can go about doing this. So no one proof is going to look the same as anyone else's. So we're going to pick one of these other angles. Maybe let's pick A, and we're going to say, okay, how does D connect to A? And then how does B connect to A? Okay, so we can see that angle D and angle A, those are supplementary angles, two angles that add to 180 degrees. We can also see that angle A and angle B are supplementary angles because those also add to 180 degrees. So I made those statements here. We could either say that they're supplementary or that they add to 180 degrees, and our justification is the definition. So we know that two adjacent angles that form a straight line or a straight angle are supplementary. They will add to 180 degrees. And again, there's different ways you can go about justifying this. It doesn't have to be word for word verbatim, but we need a statement or we need some kind of a reason as to how you know that this is true. Now, we're always going to go back to what it is that we're trying to prove. We have to show that D is equal to B. D is on the board and B is on the board. So what are we going to do with these pieces in order to ultimately show that D is equal to B? And then hopefully you can see that both of these have plus A equals 180 and plus A equals 180. So let's try rearranging these so we can isolate angle D and then we can isolate angle B. I can isolate angle D by subtracting angle A from each side. So that's going to give me 180 degrees minus angle A on the right. And then similarly, I can isolate angle B by subtracting angle A from both sides. So now if I look at this, always go back. This is what we're trying to get to. I can see 180 degrees minus angle A and 180 degrees minus angle A. Now remember, if two quantities are equal to the same quantity, therefore those quantities must equal each other. Do you remember what that's called? That's the transitive property. So by the transitive property, we can now bring these together and reach our conclusion. Therefore, we have now proved that vertically opposite angles are going to be equal. So this is now going to be true in all cases. You'll notice for justifications, a lot of times what we're trying to do is bring in that third piece of information. We're algebraically rearranging to ultimately get what we want. And then if we can see that two quantities are now equal to each other, those brought together by the transitive property will oftentimes prove what we're trying to show. In our second example here, we are ultimately trying to prove that angle 1 is equal to angle 7. Now, we know angle 1 right here and angle 7 are alternate interior angles. We also know that these two lines are parallel. So if two lines are parallel, alternate interior angles we know are equal. However, we can't just say that. That's a statement. That's not a proof. So in order to prove this, we have to bring in at least one other angle in order to somehow connect it and then go about it that way. So as you can see, if we're ultimately trying to show that 1 is equal to 7, we have 6 other angles we could potentially choose, and it doesn't matter what you pick. So if we were to do this on an assessment, you're going to see we'd probably end up with 35 different proofs. There's not one way to go about this. So which angle would you like to use? We're going to pick, and again, it doesn't matter. Maybe let's choose angle 3. So how is 3 connected to 1? Well, we can see these are vertically opposite and are therefore going to be equal. Now we're going to say, how is angle 3 connected to our other angle, angle 7? And again, we can see that these are corresponding angles, and because the lines are parallel, corresponding angles are equal. So if these two angles are equal and these two angles are equal, by the transitive property, 1 then has to equal 7. So figure out what's that third piece you're going to bring in, see kind of how they relate, and then in your head kind of get an idea where are you going with the argument, and then we can begin to develop it on paper. Okay, so in terms of the justification, 1 is equal to 3 because they are vertically opposite. Vertically opposite angles are always equal, and as you can see, these are not parallel lines. Now, angle 3 and angle 7, these are corresponding angles. Those are the armpits of the F. They are only equal if the lines are parallel. So you have to make sure in your justification you specify the lines happen to be parallel in this example. That's why they're equal. And then take a look at this. We need to show 1 is equal to 7. 1 is on the board, 7 is on the board, and they're both equal to 3. So maybe let's just kind of indicate this. So if two quantities are equal to the same quantity, therefore, they must also equal each other. So we're going to say, therefore, angle 1 has to equal angle 7 by the transitive property. You've now proved, other than just stating that they're equal because they're alternate interior, that they in all cases will be equal when we have those parallel lines. I want to take that same example and just show you how we could go about this a different way. So we've used angle 3 already to connect 1 and 7. What other angle could we use? And again, we have multiple possibilities here. So let's say maybe we choose angle 8 this time. Well, we can see 1 and 8, those are co-interior angles. We know they are supplementary when we have parallel lines. And then how does angle 8 connect to angle 7? We can also see that these are supplementary angles, and so if both angles are supplementary, we can go about our proof that way. And again, when you're stating your justifications, make sure you specify. So in terms of 1 and 8, they are only supplementary because those lines are parallel. So co-interior angles are supplementary only if the lines are parallel. So make sure you get that piece in there. And then we can see that 7 and 8, you can either say these form a straight angle that equals 180, or in this case, two adjacent angles that form a straight line are going to add up to 180 degrees. And then again, take a look at this. Go back always. What are we trying to show? 1 is on the board, 7 is on the board. How can we get rid of the rest of those statements to ultimately get this? And most of the time it's going to be algebraic rearrangement. These little tick marks indicate we're doing the same thing for each of those equations. And then we can see when two quantities are equal to the same amount, therefore they are going to be equal to each other. Now, there's so many ways you can do this, but what you want to have an idea of before you start, you do not want to be writing down every single relationship that appears because you're going to confuse yourself, and then a lot of times people end up going in circles. So choose a third piece, see if you can right off the bat figure out how does it connect to each of the angles that we have to show ultimately equal each other, and then can you develop the proof around it. Okay, and in our final example, we have to prove that co-interior angles, that's that C pattern, are supplementary. Now we know that's true if the lines are parallel, and we can see that here we have parallel lines. So we're ultimately, in this particular example, trying to show that angle 1 plus angle 4 is going to add up to 180 degrees. So therefore those angles are supplementary. Here's angle 1, here's angle 4. Because the lines are parallel, we can see that they're co-interior, we know they're supplementary, but in order to prove it, again, we need to bring one other piece of information in. So do you want to use number 2 or do you want to use number 3? Okay, so maybe let's go with number 2. So if we go with number 2, how does 2 connect to number 1? Well, we can see these are straight angles or supplementary angles. They're going to add to 180. Then how does angle 2 connect to angle 4? And again, these two angles here we can see are alternate interior angles. Because those lines are parallel, those are going to be equal. So let's maybe start there and then see how we can develop this. And now you're always going to go back to what we're ultimately trying to show. So this is pretty close to that. The difference is we need a 4 and we have a 2 in our statement, but we can see that 2 is equal to 4. So because these two are equal, I can replace that with the 4, and then we're going to get what we're trying to show. Now, I did a little bit of manipulation with my equations just so it would work out here. So if I want to ultimately replace the 4 with the 2 here, I started by isolating that 2. So I moved this angle 1 over. So algebraically, I rearranged that first equation. And then because those two are equal, I can now say, okay, angle 2 is equal to angle 4. So I substituted in the angle 4, and we can do that by the transitive property because these two quantities are equal to the same quantity, therefore they must be equal to each other. And then if you take a look, this is really close to this one. We just have to rearrange it again in order to get it in this format. So now I've added angle 1 to this side, added angle 1 to this side, and now we have what we are ultimately trying to prove.